Hi, and welcome back to the YouTube video lectures for Chemistry 103. This lecture focuses on Section 6 in Chapter 1, and that is on measurements and units in chemistry. I was going to have this video also cover Sections 7 and 8, but it would make the video too long, so I'm breaking it up a bit more. And I'm actually going to direct you to videos by another teacher who I think is really, really great. And typically I'll be making my own video lectures because I want these lectures tailored to our class. But in this case, this guy is exactly on the same page as me, so I will give you the links at the end of this video for the next two that I would like you to watch. So before we start talking about the units and the nuts and bolts of this topic, let's talk about what it is that we are measuring. We're measuring extensive and intensive properties in chemistry of all sorts of different materials. And just to give an example, we're going to do a lab later on in this semester where you will synthesize biodiesel from waste vegetable oil. And when you're doing a process like that, it's very important to be carefully measuring your reactants, your products, and really seeing how well your reaction has gone to completion, and what the quality is of the biodiesel that's generated from a reaction like this. So in an experiment like that, you'll be measuring extensive and intensive properties. Extensive properties depend on how much material is present. So these are things like mass, length, volume, where it's pretty obviously if you have more of the material in question, it's going to take up more space. It's going to have a greater mass. Intensive properties sometimes might be the more important ones. They're things like density, temperature, color, and how well your substance is performing. How in terms of this biodiesel that we're going to be making, how well does it then burn? How pure is it? So those are intensive properties. Now we talked about matter already. It's anything that occupies space and has mass. To measure the mass of matter, the SI unit is the kilogram. SI stands for Système International. It's a French governing body for all things measurement. And the kilogram it's not the base metric unit. The base metric unit is the gram. The word kilo, or the prefix kilo at the beginning of that word, means that in a kilogram there are 1,000 grams. Now, one thing that I just want to differentiate real quick is the difference between mass and weight. And weight incorporates the gravitational pull on an object. So here on Earth, we've defined it so that mass and weight are equal. But you could think of it in terms of a formula. Weight is equal to a constant representing that gravitational pull times mass. And so on the moon, everything is only 1/10 the weight it is here on Earth. Okay, so let's talk about these units now. I want to focus really just on the ones that we'll use a lot in class. And these are the units for length, mass, time, temperature, and amount. The meter, kilogram, second, Kelvin, and mole. And we'll be seeing these a whole lot. So make sure you're familiarizing yourself with them. One thing to note is that Kelvin is, the symbol for it is a capital K. In general, most of the units that we'll be using are lowercase. You may be wondering, I've heard of a liter before. A liter is a metric unit. Is that not an SI unit? Well, it is not the base unit because you can define volume just in terms of cubic length. So the SI unit for volume is the cubic meter. This is a derived unit because it's just kind of defined in terms of length units. So here I've got a picture of 1 cubic meter, obviously not to scale on your computer or iPad or whatever you're watching this on. But imagine this 1 cubic meter, so about 3 feet on each side. And let's calculate the volume in terms of some of these other units that you'll be often seeing for volume measurements in this class. The formula for calculating volume is just length cubed, one side times another times a third. And if we define this cube instead of in meters in decimeters, which is 1/10 of a meter, you can see that there's 10 little cubes going across each side of this cubic meter. If we were to find the volume in cubic decimeters, we would just multiply 10 times 10 times 10. And that will give us a volume of 10 to the third cubic decimeters, or 1,000 cubic decimeters. Now, we're going through this exercise just so that you can kind of have a conceptual understanding of what these cubic units are and what they look like. In class, I'll be going over a more step-by-step way to convert units using including volume units. Now, also, if we zoom in on this bottom right cube, it's a cubic decimeter, and you could kind of go through the same exercise in defining the decimeter in terms of centimeters. And if you remember anything from this slide, remember what's in this little box here on the right? These are very handy just to have memorized. And this is the relationship between cubic volume and liters. Two equalities that you want to know are that 1 milliliter is equal to 1 cubic centimeter, and 1 liter is equal to 1 cubic decimeter. Just so you have an idea of how big we're talking, those little pipettes there on the in the picture are 5 mil pipettes, and they're about 4 or 5 inches long. So mils, cubic centimeters are really quite small. And then the decimeter, you can kind of picture what 1/10 of a meter might look like. If you're talking about a liquid, then we often would put it in a 1 liter flask, and you'll see some of those in lab on Thursday. Okay, moving on to the prefixes. To some degree, this is an exercise in memorization. You do need to have the prefixes outlined by this box memorized. And I really only focus on mega through nano because these are the ones that we use the most in chemistry. And I'm not going to read through this list. You have it here to pause and look at. But the idea is that each of these prefixes just modifies any of those base units. So a megameter is 1 million meters, 10 to the 6th meters. And going down to the smallest prefix, nano, a nanometer is 10 to the -9th meters. And when we get down to that small, we're starting to approach units that can actually measure lengths of molecules. Density is another intensive property that we'll be measuring in lab and we'll be talking about in class. The SI unit is kilograms per meter cubed. More often, the more common units for density that you see are grams per centimeter cubed. And since centimeter cubed equals 1 centimeter cubed equals 1 mil, you'll often see grams over mil or milliliters. If you haven't, you've probably seen the formula for density before, but density is a measure of how much mass is in any given volume. And so it's very useful for calculating the total mass if you know the volume and the density of something. And the formula for that is just D equals M over V. And it's always good to kind of have a frame of reference. The density of water is 1 gram per centimeter cubed. When you get to some of the more denser elements on the periodic table, like mercury, gold, and osmium down there, then the densities are much greater than 1. Most familiar liquids and solids that we're around are between about 0.75 or so and less than 10. Greater than 10, and we're talking about usually pretty specific elements. Temperature. Fahrenheit is what probably all of us are most familiar with, but in chemistry, everything kind of happens at, everything is measured in Celsius, and when we're talking about gases, we often use Kelvin. So let's look at each of these scales. Here's the Celsius scale. The important points on it are the freezing point at 0 degrees Celsius and the boiling point at 100 degrees Celsius. Nice round numbers, much more logical than Fahrenheit, where freezing is at 32 and boiling is at 212. Kelvin is simply Celsius plus 273.15. And we use Kelvin in chemistry because 0 Kelvin is equal to absolute zero. So this makes this scale very handy for gases, and we'll get into why later on in the course. The conversion between Fahrenheit and Celsius is not as straightforward. For finding Fahrenheit, you need to multiply Celsius temperature by 9/5 and then add 32. So one quick story before we move on, and this was in your textbook as well, but in 1999, and I actually remember when this happened, you guys probably don't because you were quite young, but in 1999, there was a satellite, the Mars Climate Orbiter, that was planning on landing on Mars, and it didn't. It completely miscalculated, and when NASA did a fact-finding mission to figure out what was going on, it turned out that one of the scientists at NASA, you'd think that these rocket scientists would know this type of thing, but they had an incorrect metric conversion. So pound is the English imperial unit. A newton is also a measurement of weight, but 1 pound does not equal 1 newton. 1 pound equals 4.45 newtons. So this error affected how the orbiter was, its trajectory and the inputs into its flight patterns, and it ended up being destroyed. So, so that's it for now. Wanted to pull up that link for you, and I think I'll just annotate this video. But I've got 2 links. One video is on significant figures, and one video is on dimensional analysis, or as my colleague calls it, the factor label method. So I direct you to those videos at this point. I think they'll be very useful to you. And thanks for watching.